Good morning. Wanted to do one more example of solving or graphing a polynomial function for you guys. I mentioned on Monday that I would put this video up. Sorry, it took me a couple days. I slipped my mind a little bit there. So here's just one more example of working through sketching a polynomial function, help you get ready for tomorrow's quiz. We said we want to find x-intercepts and y-intercepts first, so let's focus on x-intercepts. X-intercepts occur when the function is equal to 0. So if we set the whole function equal to 0, we need to first look and see how we can factor this. Hopefully we see that there's a common factor here of x cubed. So if we set equal to 0, or excuse me, equal to 0 here, we have x cubed as our common factor. That leaves x squared from the first term, plus 6x from the second term, plus 9 from the third term. That can still factor a little bit more. That gives us x cubed times x plus 3 times x plus 3 if we factor this trinomial. This is a nice example here because it helps us focus on multiplicity. We have x cubed would equal to 0. We also have x plus 3 would be equal to 0, and that actually happens 2 times from these two different factors, or two repeating factors. So here we have x equals 0 is our first x-intercept, and that has a multiplicity of 3. Here we have x equals negative 3, and that happens 2 times, so that has a multiplicity of 2. Remember, that's really important for how to determine how the x-intercept behaves. Next, we would move on to the y-intercept. The y-intercept is what we get when we plug 0 in for x. So f of 0 would be 0 to the 5th plus 6 times 0 to the 4th plus 9 times 0 to the 3rd. We plug zeros in and everything drops out, and we just get left with 0. Another thing we mentioned was if x equals 0 is an x-intercept, then y equals 0 has to be the y-intercept. So now we have our x-intercepts and our y-intercepts. All we really need now is to determine the end behavior. And the end behavior, we just want to know what's the leading coefficient and what's the degree. The leading coefficient is 1. It's 1 in a lot of cases. And what's important about it is that it's positive. And a positive leading coefficient means the function rises to the right. The degree is 5. What's important about the degree is that it's odd, and an odd degree means we have opposite tails. Okay, now we're ready to graph. Let's graph the points that we know. We've got x equals 0 and x equals negative 3. Those are 2 points that we know. So at x equals 0, which is also our y-intercept being fulfilled there, and then at x equals negative 3, there are our intercepts. Those are the only 2 points that we can actually know for sure. One of the steps we mentioned in the beginning of the notes here was to plot additional values as needed. If you feel like you want to see some more values to get a good idea of what's going on here, feel free to go and plug in some values. I'd recommend maybe 1 or negative 1, a couple of small values to get a sense of what's going on. But really, just with these 2 points and end behavior, we can get a good idea of what's going on with the graph here. And also working with multiplicity. Multiplicity tells us that at x equals 0, there's a multiplicity of 3, which means the function is going to cross the x-axis because it's odd. And being a higher multiplicity means it's going to kind of wiggle as it goes across, right? So we know it's going to wiggle as it moves across the x equals 0 intercept. Then at negative 3, we have a multiplicity of 2, which means we know that at that point, it's going to actually be a turning point on the graph. Right? Multiplicity of 2 means that we'd have a turning point. Any even multiplicity means that that x-intercept is a turning point. So we know it wiggles as it crosses at x equals 0, and that it turns around as it gets to x equals negative 3. The end behavior, we know it rises to the right, and that we have opposite tail, so that means it's falling to the left. And that's already matching up with what we've got up here with our x-intercept. You know, it has to fall to the left, it has to rise to the right, And in between, we just need to connect the dots. So it's going down as we come out of -3. It has to be coming up by the time it gets to 0, so somewhere it has to turn around in there. And that turning point could be anywhere in between the two. We don't really know where it is, so just kind of eyeball it there. And that's a fairly decent view of what our graph for this function f would look like. Okay, so again, find x-intercepts, find y-intercepts, use multiplicity and end behavior to determine the overall shape of the graph, and this is a perfectly good sketch. You're not going to get docked points for having a wiggly hand or whatever. Just make sure it's a relatively smooth curve and that the x-intercepts are behaving properly according to their multiplicity. So there's just one more example of graphing a polynomial function. Again, email if you have any questions in terms of getting ready for tomorrow's quiz.